scientists have found that those elements that have less amount of electrons in their outer layer of orbit, right? Because we have protons in the center and then electrons going around in circles around it. In its atomic structure, it's said to be that the inner structure of electrons can only be two, right? So we have two electrons in the inner circle, the first inner circle. Then the second circle, we can put up to 8 electrons, right? So that equals 10. Third layer can equal up to 18, which that makes it 28. Then the last layer can be up to 32. And it could be more because there's more elements that have more than 60 electrons. Atoms want to balance themselves out, so they need to have the same amount of protons and same amount of electrons in its atom. Since it has one electron in its outermost layer of orbit, it's easier to get knocked off into being a free electron. So what happens, it's if you have another copper atom that's 28 electrons, it's going to want to pull the extra electron from the other element. And so since, there's a bunch of atoms composed of 29 electrons, it's going to want to pull it from them. And so that's how electricity works. It pulls electrons through its atoms, right? And it does it almost instantaneously, right? So that's why this is more of a theoretical aspect, but it happens in a flick of a second, right? That's the flow of electricity. It's knocking off electrons from one atom to another and moving them through a cable. If you have more amperage, right? Let's say you had a smaller battery, it would create heat, right? The more that you have amperage, then you create more heat because you're having to, for example, if I were to carry 600 pounds, then I would be struggling, right? So it's creating tension and friction because it's having to work harder to pass that electricity if it has a lower voltage battery. If you're creating heat, then that could potentially wear out or burn out.
I remember doing that in high school physics class too, in the labs, like doing simple circuits. But it's crazy to me how, you start with something simple like that when they first discovered electricity. And now here we are decades later, and we have extremely advanced, complicated circuits. But really, when it comes down to it, it's just a simple circuit. All of these complicated cars and computers and machines, and the Zoom call we're doing right now, it all comes down to circuits. It's just a simple series of combinations of wires and metal that's plugged into a wall, which is the same thing, combination of metal and wires and electricity that forms these complicated things that we're doing right now.
Yeah. If you put it in that format, you start thinking, it's almost like what we were talking about in the previous podcast from last week, where, you start questioning reality. It's like, whoa, if everything is just metals, bulbs, and wires,
that's all it really
then what is reality?
that's
right?
all the computer is right now. Our perception of reality, of talking to each other in a conversation, is just a culmination of pieces of metal and electricity and electrons. I mean,
if you put rags with oil and you just put them on a pile, they can burn. They without moving, they'll start catching on fire.
What?
Or smoking. And that's because they in a molecular level, everything's still vibrating. So the oil is still moving, and creating a little bit of friction at a very molecular level.
I didn't know
and
that.
So that little friction is almost like the little eraser, right? That is just creating more friction. And so that's why the racks, they have to put them in a metal container so that it contains a possible fire.
I wonder if that's what makes oil more flammable, is that friction and vibration that you're talking about. It's really weird. It's like when you start diving into what makes things the way they are, it gets kind of strange. It's almost like you're uncovering a veil that has covered the way things are. It's like looking behind the curtain, behind the scenes of reality.
One has to be careful because you could conduct the electricity through your body. So because we're good conductors, I start thinking about this and maybe how previous civilizations might have used human beings as batteries. I mean, I'm thinking like, something along the lines of the Matrix. You know how computers started
Oh
being
yeah.
getting too smart, and then they started using actual human beings to power, yeah, like batteries to power their civilizations. And so, is there like something at a molecular level that human beings can carry electrical current, or like, or maybe we just carry emotions, right? Like we can conduct emotions, or we can conduct other things like thoughts. A lot of people think that we are like antennas, and that God is like an all-knowing thing, or like a cloud that's everywhere and like anywhere and everywhere. And then we can tap into that to God, or that consciousness, and be receptive to it, right? And receive ideas.
I mean, the transfer of like cells, like things in and out of cells, has to do with electric charges and stuff of the elements, all that.
Really?
Yeah, like
Wow.
I can't remember what it was. It's been a long time since I've taken biological psychology, so yeah, I'm trying to remember there. I think there's like chloride ions or something that get transferred in and out of the cell. I know there's some type of electrical thing involved with with the way neurons function. You know, that synaptic gap. There's electric charges that go between the synaptic gap between neurons, between dendrites and axons. And so, like, there is some type of electrical reaction that has to peak up and then peak down. I think it's called I think it's called the electric potential or something like that. But once the neuron reaches that electric charge, and then it dips down right away. So it's limited, it's limited. Once it reaches that peak, it has to have a refractory period before it can have another chemical electrical reaction. So
Yeah.
that's in our brains all the time. It's just fun.
Yeah. And
That's how electrical appliances function with electricity as well. And we also function with electricity. And
yeah.
every
And
atom
and it's interesting
electricity.
because like what you're saying is like we maybe, but like because people like might be hearing this and think like, well, that's a chemical like reaction. And yes, like chemical reactions can also cause electricity to happen. Like
Elect-
electricity is not just, with like batteries. Like batteries are also chemicals like within them, and so like